Hello and welcome. Today we're going to be looking at a basic projectile motion question. This is one where it says a small child slides a plastic toy off a counter with a velocity of 2.50 meters per second. The counter is 1.15 meters tall. Excuse me. How long does it take to hit the floor, and how far away from the base of the counter does it land? All right. In this case, the plastic toy is slid directly off the counter, and so there is no initial y velocity. It's not thrown up in the air. It's not thrown down from the high chair. It is just slid off the counter, and so it's going to have only an x velocity. Let's real quickly set up our table of values, and let's go ahead and label the parts of our diagram. So let's see, so here's going to be our velocity, which is going to be 2.50 meters per second. The counter is 1.15 meters tall. And the question is, how far away does it land? So this distance right here is what we're interested in. And that, of course, is the change in the x position. So delta x or delta d in the x dimension. All right, real quickly, let's draw a table of xy information and solve using that. Okay, and so here we have our x, here we have our y. The velocity in the x dimension is 2.50 meters per second. Since there's no air resistance and nothing in the x dimension getting in the way, the acceleration in the x dimension is 0 meters per second squared, which is why this is both the initial and the final velocity. Because remember that the acceleration is the rate of change of a velocity, and since the velocity is not changing, it will be constant the entire time. Okay, delta x is what we're interested in, and we're also interested in time, and we don't know either of those. In the y, the initial velocity in the y dimension is 0 meters per second because, as I mentioned earlier, it's just slid directly off the counter, not up or down at any angle. The acceleration in the y dimension will be the acceleration due to gravity. I'm going to put it as negative 9.8 meters per second squared. That means that this displacement in the y dimension will also need to be negative because it is downward. If you wanted to leave both those as positive, you could, and it would be perfectly fine, but those signs need to match. All right, and then we're looking for time, and we do not know it. We have a lot more information in the y than we do in the x, so let's go ahead and look to solve in the y dimension. I'm going to choose delta y equals VIT plus 1/2 AT squared. My delta y is negative 1.15 meters. My initial velocity is 0, so that's going to zero out that term. And I'll just have plus 1/2 times negative 9.8 t squared. So negative 1.15 equals negative 4.9 t squared. And at this point, I'll divide both sides by negative 4.9 and then take the square root. So you pause the video for a moment and finish that calculation. All right, hopefully you finished that, and I got that t is equal to 0.48 seconds. So just short of half a second, 0.48 seconds. All right, and so there is one of our answers, and let's take that now and figure out how far along the item lands. So let's see, delta x, we're in the x dimension now, so I've switched that from delta y to delta x, equals the velocity times the time plus 1/2 at squared. Now the a is 0, so that's going to zero out that whole term. And my delta x will be equal to my velocity, which is 2.5, times my time, which is 0.48. Okay, and when you do that, you'll get just under 1.25 meters. Let's see what I get. Times 2.5, 1.21. So delta x equals 1.21 meters. All right. And that is the basic idea of projectile motion. Again, remember that the most important thing is to keep your x and your y dimensions separate, because neither one affects the other. They are both completely independent. And so as long as you remember to work that and are careful getting your givens, then you will have great success. I hope that was helpful, and have a great day.